Hello everyone, welcome back to our tutorial series. Today, in this 20-second episode, we're going to delve deeper into some advanced string manipulations using Excel VBA. If you missed our previous video, episode 21, where we introduced string manipulations, I recommend you check it out first, as this video is a continuation, exploring more complex and interesting aspects of the topic. Today, we'll be covering several intriguing elements such as locating substrings, understanding string lengths, dealing with multiple occurrences of substrings, and more. We'll also learn how to effectively split a string into an array of substrings and join them back together. So, if you're ready to enhance your VBA skills and dive deeper into string manipulations, let's get started. Great, now let's look at our VBA editor and dive into the first code segment called Searching Substrings. This subroutine uses the built-in inString function to locate the position of the substring Hanks within our string in cell A1. When it finds the match, it returns the position as a number, and that number is then displayed using a message box. The inString function is a powerful tool in VBA's arsenal due to its capability to rapidly pinpoint a particular text segment within a more extensive string. This becomes incredibly handy in data analysis, where large datasets might need to be sifted through to find specific data points or patterns. For example, we could use it to identify specific keywords in customer reviews, locate a specific name in a list, or even detect specific codes or values within larger datasets. By simply indicating the string we want to look through and the substring we're searching for, the inString function gives us the starting position of the sought-after substring in the main string. Now let's go ahead and execute this code to see how it works in action. As you can see, the message box shows 11. It indicates that the starting position of the substring Hanks is at the 11th character of our main string. Remember, the inString function counts spaces as characters. Thus, counting from the beginning, including spaces, we find that the letter H in Hanks is indeed at the 11th position. Great, now that we have learned about searching for substrings within a string, let's move on to our next function, the len function, which will allow us to determine the length of our string. Length here refers to the number of characters present in the string, including spaces and special characters. In this subroutine called Finding Length, we are using a message box to show the result of the len function, as we're interested in seeing the output in a message box. This line of code fetches the value from cell A1 of sheet 2 and then passes it to the len function. The len function then calculates the length of the string, and that result is displayed in a message box. Knowing the length of a string can be incredibly helpful, especially when you want to validate the data input or when you need to manage the string, like deciding the size of the field in a database, or while trying to trim, split, or manipulate the string in other ways. Let's run this code and see what we get. Excellent, as you can see, the message box displays the number 33. This means that the text string, Hello Tom Hanks, my name is John, in cell A1 of sheet 2 contains 33 characters, including spaces and the punctuation mark. This is a clear illustration of how the len function counts every character in the string. Again, it's worth emphasizing the importance of understanding that len treats spaces and punctuation as characters. This could be crucial when processing text data, especially when spaces or punctuation might not be visually apparent. Now let's move on to our third subroutine, which is all about extracting substrings based on certain positions. We'll be utilizing both the inString and len functions we've just explored, along with the left and right functions, to achieve this. To begin, our code first uses the inString function to find the position of Hanks in the sentence, storing this position in the variable substring position we declared as integer. After that, we use the len function to determine the total length of the string in cell A1. Storing this value in the variable string length we also declared as integer data type. Now comes the interesting part. We're using the left function to extract all the characters to the left of Hanks in our string. This function requires two arguments, the original string and the number of characters we want to extract from the left. In our case, we've supplied it with the original string, which is the text in cell A1, and substring position -1, effectively telling the function to stop right before Hanks. This result is then placed in cell A2. Next, we use the right function to extract all characters to the right of Hanks, including Hanks itself. The right function requires two arguments, the original string and the number of characters we want to extract from the right. We calculate the number of characters by subtracting substring position +1 from the total string length. Here, substring position represents the start of Hanks, and substring position +1 signifies the space before Hanks. By subtracting substring position +1 from the total string length, we effectively calculate the length of the string starting from Hanks. This resulting string, including Hanks and everything after it, is then placed in cell A3. After we run this code, we'll see that our original string has been split into two parts. One part in cell A2, which includes all characters before Hanks, and the second part in cell A3, which includes Hanks and all characters after it. So let's go ahead and run this code to see the outcome. As you can observe in cells A2 and A3, the original sentence has been split into two at the point where Hanks starts. Cell A2 contains the portion of the string before Hanks, and cell A3 contains Hanks and everything that comes after it. This is a powerful technique that you can use to segment and analyze text data more granularly. Next, we're going to dive deeper and find the second occurrence of a specific substring within a string. We have a new sentence in cell A1 on sheet 3 which reads, "Hello Tom Hanks, my name is John. My full name is John Crabbe." Notice that the name John appears twice in this sentence. What if we wanted to find the second occurrence of John in our string? Well, our subroutine called Find Second Occurrence of John is designed exactly for that. The first part of our code works similarly to our previous examples. We're using the inString function to find the position of the first John. We store this position in the variable called substring1position that we declared as integer. Next, instead of stopping our search after the first John, we're using inString function again. This time starting our search from the position just after the first letter of John. This is accomplished by adding 1 to our first found position, substring1position +1, and using this as the starting point for our next inString function. The position of the second John is then stored in the variable substring2position we declared as integer. Next, we determine the length of the entire string using the len function and store this in the variable string length we also declared as integer. With the variables string length and substring2position, we can now use the right function to extract the part of the string from the second occurrence of John forwards, which we then put in cell A2. Let's run the code and see the result. Great, now let's move forward to the fifth subroutine, called Find Last Occurrence of John. By the way, codes used in these tutorials can be found in the video description section below. Alright, now this piece of code demonstrates another interesting function in VBA, called the inString reverse function. This function is used to find the position of the first occurrence of a substring in a string, starting from the end. Essentially, it's like the inString function, but it works in reverse. Let me quickly explain the structure of this subroutine. We begin this subroutine by declaring two integer variables, last occurrence position and string length. We'll use these to store the position of the last occurrence of the word John and the total length of the string in cell A1, respectively. Here, the inString reverse function is searching for the last occurrence of the word John within the string in cell A1, and we assign the result of the inString reverse function to the variable. We then calculate the total length of the string using the len function and assign this value to the variable string length. Finally, we extract the part of the string starting from the last occurrence of John and put this in cell A3. We achieve this using the write function, which we feed with two parameters. The string we're manipulating, the one in cell A1, and the number of characters we want to extract. This number is calculated as the difference between the total string length and the position of the last occurrence of John plus 1. Alright, let's run this subroutine and see the result. Great, you can see that the result in cell A3 starts from the last occurrence of John, which is exactly what we expected from our code. Understanding how to manipulate strings to extract specific information can provide us with a powerful tool for data analysis in VBA. Moving on, let's take a look at the next subroutine, called splitting strings. This subroutine is all about splitting the string into individual words. This is particularly useful when we want to analyze each word separately. In this subroutine, the first thing you might notice is that we declare an array of strings named words. We're going to use this array to store the individual words from our original string located in cell A1 on sheet 3. Next, we're taking our string from cell A1 on sheet 3 and we're going to split it into individual words. To do this, we're using the split function in VBA. The split function is incredibly useful as it can break a text string into an array of substrings based on a specified delimiter. In this case, we're using a space as our delimiter, which is signified by the space between the parentheses in the split function. Next, we're using the loop to iterate over each element in the words array. The L-bound words and U-bound words functions are used to determine the first index and last index of the words array respectively. These functions help us define the range of indices through which the loop should iterate. For example, if the words array has elements from index 0 to 13, L-bound words will return 0 and U-bound words will return 13. The loop will then iterate from 0 to 13 inclusive, allowing us to access each element in the array using the loop variable I. Inside the loop, we're writing each element of the array, which are the individual words from our original string, into the cells of column B, starting from cell B1 and moving downwards. This expression takes each word, words I, and places it in a new row starting from row 1 in column 2. Now let's run this code and see how it takes the sentence in cell A1 and splits it into individual words that populate column B. Great, now let's move on to our final subroutine for this video. This one's called joining strings, and as the name suggests, it's going to take our split words and join them back together, but with a twist. So here's what's happening in this subroutine. First, we declare an array of strings, words, just like we did in the previous example. We then split the string in cell A1 on sheet 3 by spaces, just like before, and store the resulting words in the words array. But here's where things get different. Instead of writing each word into a new cell, we're going to recombine them into a single string. But instead of using a space as we did originally, we're going to use a hyphen. We achieve this by using the join function in VBA. The join function takes two arguments, the array to be joined, and the delimiter that will be inserted between each element of the array. In our case, we're joining the words array and using a hyphen as our delimiter. So, the final result of this line of code will be a single string made up of the words in our words array, but they will be hyphen separated. Let's run this last subroutine now to see the output. As you can see, the sentence from cell A1 is now in cell A4, but the words are hyphen separated. And there you have it. This wraps up our tutorial number 22 on VBA string manipulation. If you missed tutorial number 21, I encourage you to check it out, as it also deals with string manipulation, providing you with a solid foundation. In both of these tutorials, we've learned about powerful string functions in VBA that can significantly ease and automate data processing tasks in Excel. Thank you for watching. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe for more tutorials. And as always, happy coding, and I'll see you in the next video.